Hi, my name is Alink and today we're gonna talk about Alink. Alink is the machine learning platform based on Apache Flink that was created and now supporting by the PAI team of Alibaba's cloud computing platform. And Alink contains a variety of different ML algorithms and pre-created models that make it even compatible with a Python-based libraries on the number of available features. Some of these features were also implemented in Apache Flink 2.0, and I was mentioning Apache Flink ML in one of my previous videos. But to be honest, Apache Flink ML looks less comprehensive and solid than Alink, in my opinion. As far as I know, Alink served as a foundation for the Flink ML 2.0. Alink looks extremely interesting in terms of available AI features. Unfortunately, almost all of the available Alink documentation and references and also community support are in Chinese. And that's why it was hard to go through all the examples to create the one which we will see later. In this article, we will pass through a basic project that uses Alink to analyze the sentiment of the reviews from the imdb.com. But before we begin, I want to put some extra bullets to interest you to use the Alink features and to make you more motivated to adopt Alink in your project or just to give it a chance. At first, Alink makes full use of Flink features. That means it is scalable, it is performant, and it is a real-time engine. Alink also uses handy ML tools to build your ML pipelines, and it has a set of simple ML abstractions, imputers, vectorizers, partitioners, and others. Also, Alink has a plethora of ML methods and algorithms out of the box, and that's great. Alink also able to deserialize models to the disk, and that's, in my opinion, is a killer feature of Alink. And Alink also has a Python API for those who loves and use Python. And that's why you can use Alink in Jupyter notebooks, Jupyter Lab. So what will we do today? At first, we will find an appropriate data set to train and validate our model. Then we will split this data set into the training, validation, and testing sets. Then we'll load the training part of the data set and make some preparations and pre-processing on this data. Next, we will train the model, and we will use the training data set, obviously, to train the model. Next, we will validate the model using the part of the validation data set. Next, we will try to serialize our trained model and see how it looks being serialized to the disk. And the last step, to deserialize model from disk, to create an object from model and to make some predictions based on the deserialized object. That's all. Let's get our hands dirty and let's start. So I was searching on kaggle.com to find some kind of a data set that will fit our needs, and I found the data set from the imdb.com, and this data set contains the texts and labels, and the texts are reviews which were made by users, and The label is an integer which can be either 1 or O, and 1 stands for a good or positive review, while the O stands for a negative one. And thankfully, this dataset was already splitted or separated into 3 datasets, one for training, one for validation, and the last is for test. They all have a same structure and they are all in CSV. Well, let's create a simple Maven project, and since we use Maven, let's look at pom.xml file. There are some dependencies, and the most important dependency is this. It is Alink core Flink. I will use the version 1.10, and the latter 2 dependencies are standard dependencies for Flink. It's a Flink streaming Scala and Flink table planner. They are both used by Alink. Let's create a simple class and call it model training. This class will contain a main method, and we will run our pipeline using this main method. At first, let's use a CSV source batch operation class to create a new training dataset from the given train CSV file. So I'm creating a new instance of the CSV source batch operations class. I'm set the file path. In my case, it is a train.csv. I provide a CSV schema, and this method looks great. So I'm just pass a string here, which the first one is text column, which contains our reviews, and it is of a string type, and the second column is a label, and it consists of our sentiments. And I want to ignore the first lines, since the first line contains our column names. I don't want it to be imported into our dataset. And the second dataset I will create is a validation set, the same as for the train dataset. Expect that this is another CSV file. Just to test our CSV source, I will print the first n rows from our training set, and we will see it later in our console. And the most interesting thing is a pipeline. Basically, this pipeline is our training pipeline that will train our model, that will prepare the data for our model, that will clean, maybe even enrich our data before it will be passed to the logistic regression. And since we are talking about the sentiment analysis, in our case it would be provided using the logistic regression model. But first things first. The first step of our pipeline is the inputter. The inputter allows us to select a column that will contain our review, as I said, output column, which was a result of the transformation applied to the text column, and we want to replace the null or empty values from the initial dataset, if any, to nulls. And in our case, that's all that inputter does. The next step is a segment, and we want to split the sentences that are together construct the reviews into a set of words that are separated by spaces, and that's what the segment does. The next step is stop words remover. And I think that in some cases you want to apply some kind of filtering to your initial data. That's why you may add some dictionaries with stop words, and in that case you will filter out all the stop words from your initial data set. At the next step, we add in a doc_count vectorizer, and it calculates a feature vector from input words based on so-called tone frequencies. So the vector length here would be equals to the number of words in a given review. So TF here stands for tone frequencies. And the last step is the logistic regression, and it applies the algorithm. In our case, it is a classification model to the vectors given at the first or previous steps, and writes the final predictions to the pred column. This string will fit our model with a given training set. Let's see what will happen if we run the main method. So we see that the first 5 reviews were printed to the console as we expected before. The next line is model save, and as I mentioned before, Alink allows us to serialize and deserialize trained models to the disk. Finally, make a predictions using our model, and this will force our pipeline to train the model finally. So I will take our model and invoke the transform method, given an validation set, the first 100 rows from our validation dataset as an input. I will select the text, label and prediction columns from the resulted dataset, and I will print the first 5 results from the dataset. Let's run our method once again. Our model is finally trained and ready, and we see the training steps in the console. It took about 3 minutes to complete, and finally we see that there is a new file appeared, it called model, and if we open the file, we see that this is a serialized view of our trained model, and it resembles a combination of JSON schema with a CSV coefficients or factors that are saved as a file. And if we take a closer look to the console, we will see that there are 3 columns has been printed. The first contains text, label and predictions. Take care that the label column contains the values which were marked in the validation dataset, and the pred column contains the values given with our model. Let's look if our model was accurate enough. Okay, at the second case, the labeled value was O and predicted value was O, so it's great. The first model was labeled as 1, a positive sentiment, and the model also predicted a positive. Great. The third row was predicted faulty, incorrect. It was labeled as O in our validation dataset, but the model decided to predict it as 1. Okay. And the last one is also correct. And finally, the first one, it's a really huge review. It was also predicted incorrectly. It was labeled as negative, but our model decided to mark it as positive. I think that our model is pretty accurate, so let's go further. Now let's try to deserialize our model from the model file which were serialized a few moments earlier. I will load the validation dataset the same as we did it before, and I will create a new object of the type pipeline model called model des, and I will load it from the serialized view of our model. Then I will do the same trick. I will transform this deserialized model with the first 100 rows from our validation set and select the same columns as in a previous case. Well, let's see how it works. I run the main method and we have to wait for a few moments. Finally, it is finished and we have the 5 results. Let's check if the deserialized model is also correct. Okay, scrolling. The second prediction is inaccurate. Well, the first one is also inaccurate. Oh my god. Well, let's check the other. Oh, once again, a huge reviews here. The last prediction is totally correct. Oh my god, it's so long. And finally, the third prediction is also correct. And I hope you will be correct. Come on. And the last prediction is also correct. So our model is about 70 to 80% correct. Well, that doesn't sound bad. That's great, I guess. For a training project, that's great. So it was the last part. You can find this project on my GitHub, and I will add a link in the description, and you will see the link here at the bottom of your screen. Thank you for watching the video. Hope it was interesting. My name is Alexander Sergienko. Have a great day. Bye.